Welcome to Lesson 6. Here we focus on the few new operators that the algebra introduces of its own. With them, we'll do something that may surprise you. We will rebuild the SQL join from scratch, exactly, with no hand waving. There are really just two new ideas here. The first is restriction, a precise way to keep only the data that matches a condition. The second is lifting, a way to carry any operation up a level of the tower. Put them together, and the famous and ubiquitous join appears, as if by magic. Here's the plan in one sentence. With restriction, we can pick out exactly the rows we want. In SQL, that's the where clause. With lifting, we can take any operation defined on relations and apply it across a whole clan of them. And once we have both, the join, that complex operation that SQL champions, turns out to be nothing more than restriction and composition, lifted and combined. Everything you do in SQL can be re-expressed in the algebra, precisely and often more clearly. Let's take the two new ideas one at a time. The first new operator is restriction, and it comes in two mirror forms. Superstriction, written with a triangle pointing right, keeps a relation only if it contains what you're looking for and discards it otherwise. Substriction is its mirror. That sounds abstract, but you already use it constantly. It is exactly what the where clause does. It keeps the rows that match and drops the rest. And when we lift it to a whole clan, cross superstriction runs that same filter across every relation, every row in the table. This is filtering, precisely defined. Let me show you how neatly the SQL you probably know lines up with the algebra. Select, choosing which columns you want, is composition. It follows each row into just the columns you name. Where, filtering the rows, is superstriction. And join is the natural join, which we're about to build. The point is not that the algebra replaces SQL with something alien. It's that SQL, for all its quirks, was always doing algebra underneath, without the clean foundation. The algebra simply gives the same operations an honest mathematical form. Now the second idea, lifting. It's the simplest thing in the whole algebra. Take any operation you have on relations and apply it to every pair of relations, one from each clan, collecting the results. That's a cross operator. We mark it by drawing a broken circle around the familiar symbol that is being lifted. Cross union, cross intersection, cross difference, cross composition, cross restriction. They're not new operations to memorize. They are just old ones, carried up a level. And here's the reward on the sixth card, the natural join. It is not a primitive at all. It is restriction and composition, lifted and combined. Step back and see the shape of it. Every operator in the algebra either lives at the foot of the tower or is a lifted version of one that does. That's why 23 operators is far less daunting than it sounds. Most are the same few verbs, carried upward. Lifting is the engine of the whole system. It's what lets one small set of ideas cover tables, documents, graphs, and databases without ever growing a special case. Learn a verb once at the bottom. Lifting delivers it faithfully everywhere above. So, to summarize, restriction, superstriction, and substriction is the where clause made exact. Keep what matches. Lifting turns any relation level verb into a clan level one by applying it to every pair, and we mark it with a broken circle. And the join, that intimidating cornerstone of SQL, is simply restriction and composition, lifted and combined. No magic is required. With that, you've met the whole family of operations. In the next lesson, we climb the final rung of the tower. So that's the algebra's own operators and the join laid bare. Thank you for your time. In lesson 7, we have a little more to say about the strictions.